So welcome to our session today on Marine Cloud Brightening of the Great Barrier Reef. And I'm extremely happy to be chairing this session. Firstly, I'd like to introduce our panel. Now, Dan Harrison is online. And there's Dan. Now, why don't you say, you're on our screen there, Dan, you can say hello.
G'day everybody, it's Dan here. I'm peering from Australia. It's a little bit late here, but it's very nice to be with you all.
So what must be near midnight for you now?
Getting towards it, yeah.
That's very good of you to stack it up. And then I'm also Clara Botto, who is currently based in the University of Cambridge, which is great. And she's part of the Alliance for Just Deliberation of Solar Geoengineering. And then from Ocean Visions, we have Leonardo Valenzuela Pérez. And then myself, I'm from the Centre for Climate Repair in Cambridge. Now, the whole topic of marine cloud brightening, I just want to put it into context. So, first thing to talk about is a thing called a napkin diagram. And I have a real napkin. Nice thing about the napkin diagram is that when you're in the pub or a bar, you can sketch this thing out and you basically say business as usual is at the top of business as usual means the temperature rise a lot. And we need to avoid temperatures rising a lot. Emissions reduction. Of course, we need emissions reduction. We've got to stop burning fossil fuels. But unfortunately, that's happening a bit slowly. I mean, here we are in COP30. It's happening a bit slowly. But we will get off fossil fuels. That'll happen. But we may well be left with still a 4 degree, say, I don't know. And that's unacceptable. We know that the negative emissions concept that we've got to take carbon dioxide and other greenhouse gases out of the atmosphere. That's very important. And that's number 2, carbon dioxide removal. But that too, the technology is going again slowly. But it will happen. It's going to happen. And the oceans are going to hopefully get better at sucking up CO2. But it may be a couple of hundred years before we get back down to perhaps 1.5 again, which is kind of where we are now. In the meantime, we're going to get what's called overshoot. And we may end up with temperatures 2.5, 3 degrees, which we can't live with. We've got to do something about it. So that's where all this solar radiation management or solar radiation modification or sunlight reflection methods, SRM, that's where that's coming. It's not an alternative to 1 and 2, but we have to do all 3 together. Now, what is SRM? Well, here are some examples. You may have heard of stratospheric aerosol effect, and it's a bit scary, the idea of putting sulfate aerosol, sulfuric acid in the stratosphere. This is the one that really has given geoengineering a bad name, and for we haven't really got in us now to think about putting sulfuric acid into the atmosphere, given that we spend so much time getting rid of it. Other ideas, there's space reflectors. So this also sounds very science fiction and scary. So we've got to be careful not to be too excited about science fiction. But science fiction may be, but there's a lot of good research going on both of these, space reflectors and stratospheric aerosol. There's also good research going on how we can cool cities by having good reflection, having white roofs on houses and good ideas to reflect sunlight down at ground level. What we're particularly talking about today is Marine Cloud Brightening, MCB. So a lot of us read that acronyms in this world. And Marine Cloud Brightening is essentially that about 30% of the sunlight that heads towards the Earth is reflected back into space And that's just the way it is. And it's reflected on clouds, it's reflected in the stratosphere. If we could increase that reflection from 30 to 31%, then that might give us a 2-degree cooling of the whole planet. Now, this is all nice with global climate models and so on. We've really got to do research to find out whether that's going to work. Now, Dan Harrison in Australia has been doing work on Marine Cloud Brightening as a regional cooling technique, reflecting sunlight near the Great Barrier Reef. So I'm going to head over to Dan. He's going to tell you his perspectives on the Marine Cloud Brightening as it applies to his work in the Great Barrier Reef. So over to you, Dan.
Thanks, Hugh. I'll just share the screen. Good day, everybody. So my work is part of the Reef Restoration and Adaptation Program in Australia, which was established in 2020 to look at all the different ideas that we could think of that might be able to help the Great Barrier Reef survive climate change. And so this ranges from things like trying to genetically alter coral to be able to withstand higher temperatures, selectively breeding coral, restoring reef, all the way through to the work I'm going to talk about today. And the motivation for this was obviously the plight of the Great Barrier Reef over the last 5 or 6 years, well, 8 years now. We've had 5 mass bleaching events on the Great Barrier Reef. And you can see that we've really crossed a threshold here in global warming where the water during summer can just become too hot for the corals and they die. Well, sorry, they bleach, they become stressed and they expel their symbiotic algae. And then if the heat stress stays too high for too long, then they can also die. And you can see on the map on the right there that there's nearly no part of the Great Barrier Reef that hasn't been affected by this now. And the future looks quite grim as the climate continues to warm. But there's something else interesting that's been happening, and we just had recently our worst mass bleaching event ever on the Great Barrier Reef, the most extensive and the most severe. And also we are now starting to see coral bleaching events in La Nina years as well, which are typically cooler on the Great Barrier Reef. And this coincides with this fairly sudden jump in global temperature that we've seen over the last couple of years. And you can see that the last couple of years plotted there in the colors, the red and the orange, just the entire world for the entire year has just jumped outside the natural variability. So we've sort of been rising steadily in warmth in the globe, and then we've just suddenly had a stepwise increase in temperature. And some recent science out has attributed fairly unambiguously, I think, using satellite analysis, that they can attribute that increase in temperature that we've seen just in the last few years to a change in the albedo of low cloud. So there's a little bit less low cloud and it's a little bit less bright than it has been. And so that's caused this sort of 0.2 or so degrees temperature jump that we've seen, sort of an acceleration of global warming, but just a bit of a jump. And before we try and explain why that might be, we have to go back here and look at the IPCC summary of all of the radiative forcing of the planet. So everything in reds and oranges are anthropogenic activities that have increased the radiative forcing. So they're things that warm up the planet. And the things in blue are things that humans have done that cool down the planet. And so you can see that the sort of the greenhouse gases here and some land use change, and that there's not a lot of blue basically. But the one thing that we are doing that has really a major cooling effect on the planet is we're releasing these extra particles into the atmosphere, which are called aerosols. So just any particulate matter floating around in the air, tiny little particles are called aerosols. So we have the aerosol cans, and they're called that because they release tiny little droplets of whatever it is that you're spraying. And so we can see in the blue here the cooling effect of aerosols. The darker blue there is the direct scattering of aerosols in the atmosphere. And so stratospheric aerosol injection that Hugh was talking about a moment ago is designed to try to add more sulfate particles to the very upper atmosphere, to the stratosphere, and that those will stay there for some time, and each little particle reflects some light away from the Earth. And so that's this dark blue effect, because we're already adding particles to the atmosphere, and some of them are reflecting light away from the Earth, and that's called the aerosol direct effect. But this much larger cooling effect on the left here in the lighter blue color, that comes from aerosols' interactions with clouds. And so what this is telling us is that all of these extra particulates that humans have been adding to the atmosphere since the Industrial Revolution are interacting with cloud and have been cooling the planet down. And there's a few modeling studies out now that look at this change that we saw, this sudden jump in global warming, and attribute at least half of it, perhaps more, to a change in the sulfur reductions of international shipping. And so a few years ago, new rules came into effect that mandated a reduction in the amount of sulfur in shipping fuels by 70%. And the sulfur in the shipping fuels, this is a different idea than what he was talking about previously, but the sulfur in shipping fuels forms particulates, and those particulates are very good cloud condensation nuclei. And you can see the images on the right here where ships have passed underneath susceptible cloud, and the cloud condensation nuclei resulting from that sulfur in the fuel and other particulates coming from the ship have resulted in these very dramatic changes to cloud, where you can see them go from quite a dark background to a very bright white background. And so when we talk about albedo, the measure is between 0 and 1. And so 1 means a very bright surface, 100% of the incoming light from the sun is reflected back, and an albedo of 0 means a very, very dark surface that absorbs all of the light with nothing getting reflected back. And you can see that under the right conditions, these ship emissions of cloud condensation nuclei are change the albedo from being really quite dark to very, very bright. And this effect of the shipping emissions on clouds is overall quite a strong forcing, because the ships are out where the clouds are most susceptible. They're plying the remote oceans of the world, where the background number of particulates is very, very low. And so this brings us to the background of marine cloud brightening. So the concept was initially formed from actually observing these ship tracks over the ocean and realizing that the particulates in the ship's fuel were able to dramatically brighten the clouds. And so scientists, John Latham back in 1990, speculated that you might be able to offset global warming by deliberately brightening the clouds. And in this case, the idea over the remote oceans, approximately half of the cloud condensation nuclei that are naturally there are sulfate based, and around half are from sea salt. So when the wind blows over the ocean, it creates waves, and tiny little droplets get torn off of the waves. They evaporate, leaving the salt crystal behind. And so how do these particles in the atmosphere create cloud condensation nuclei? Well, when you have a rising parcel of air with moisture in it, water vapor, so water is a gas, as that air as it cools and becomes supersaturated as it rises, it needs a tiny little particulate to start to condense water around and to grow a cloud droplet. So cloud droplets actually grow. They start very small on a nucleus, which in this case is that particle in the atmosphere, and then it collects more and more water as the supersaturation increases and the cloud lifts and the droplets grow. And so the idea is that if you provide more of these cloud condensation nuclei, the seeds, then when the cloud droplets grow, for the same amount of water vapor, you get a larger number of smaller droplets. And if you look at the two glass jars there in the, two glass jars there in the top right corner, they both contain perfectly clear glass spheres. The only difference between the one that appears very bright and the one that appears much duller is the size of those glass spheres. And so this is the basic idea behind marine cloud brightening, that when you have a larger number of cloud condensation nuclei, when that cloud is forming, that cloud is brighter and whiter and reflects more sunlight back out to space. And the reason that we've been looking into this for the Great Barrier Reef is that it's potentially extremely powerful. When you add a tiny salt crystal to the atmosphere and it forms a cloud droplet and it condenses that water vapor, it grows to around 500,000 times the size of that tiny salt crystal that you add. And nature does all of that work for you. And then, of course, you have the sun providing the energy that's then reflected away by that droplet. And so the energetic leverage is quite high. We think we can put in a relatively small amount of energy to reflect a very large amount of energy of the sun away from Earth. And so this is happening naturally all of the time. When wind blows across the oceans, it creates these cloud condensation nuclei from seawater droplets. They evaporate, and those salt crystals form cloud condensation nuclei. We also had a look at the ship sulfur, the new regulations over the Great Barrier Reef, and we actually found that just like those shipping emissions were masking some of global warming for the whole planet, they were also masking some of it over the Great Barrier Reef. And under the right conditions, the fact that those ships are no longer producing as suitable particles for marine cloud brightening means that we're seeing quite a lot of extra heat stress onto the corals in the last couple of years. And so the idea that we've been looking at is a little bit different. It's whether you could go out and do this in a small scale just over the Great Barrier Reef at the time that the corals are bleaching. So during the sort of peak of summer, when the heat stress builds up over several months in a marine heat wave. And whether this would if we went out and we took the seawater and we atomized it and we sprayed it so that we brightened the clouds, whether this would make any difference to the corals. And so in these modeling results here, we assume that we're doing marine cloud brightening over the reef each summer. And you can see the dashed line there shows the projected trajectory of the amount of coral on the Great Barrier Reef into the future. So it's declining under the baseline scenario of climate change. And in the top panel there, you can see if we have a Paris type climate future and countries meet their targets, and we do the marine cloud brightening, it's able to stabilize the coral cover on the Great Barrier Reef. However, in the bottom panel there, in a business as usual scenario, it's not quite as rosy an outcome. We're able to stabilize coral cover for a few decades on the Great Barrier Reef, but eventually the effect that the marine cloud brightening is having is overcome. And that's because you can't just keep doing more and more cloud brightening and get more and more cooling. It's a sort of, there's a window there that can potentially be exploited in some locations with the right sort of clouds and very importantly the right sort of background aerosol concentrations. Needs to be very, very clean marine air for the cloud brightening to have much effect, but there's only a certain amount of effect you can have. And so it's just overwhelmed by climate change in the business as usual scenario after a few decades. And so there's a very important point there, I think, that at best these sort of ideas can buy us some time while we deal with the underlying problem of climate change. It's not a solution for climate change. And so we've been working on this for the last 5 years, and although there's been 30 years of theoretical research into marine cloud brightening, nobody had really gone and tried to see if it could work. And so we've been developing the technology to allow us to start to do experiments over the Great Barrier Reef to see if we can, excuse me, to see if we can actually brighten some clouds. And so it's quite a lot of engineering involved. It's a large sort of small industrial plant that's able to produce around 1,000 trillion droplets per second of seawater, and those are advected up to the cloud. And we've spent um, quite a lot of time as well developing all of the instrumentation and the methodologies to sample the various processes that are affected. Excuse me, sorry. Here you can see what this looks like in practice. Um, so this is the view from our research aircraft flying into a plume of the sea salt crystals that we've generated, where they're lifting up into a small marine cumulus cloud here, which will just fly underneath to sample the sea salt crystals that we're creating before we'll later fly up higher and start to fly back and forth through that cloud, sampling the microphysical properties of that cloud and comparing them to surrounding clouds that were not impacted by our sea spray. So I'm sorry, I'm getting a bit sick. I'll go quick on this slide, but this work hasn't been done in isolation of just the scientists. It's involved a very large amount of community engagement and engagement with our various stakeholders, including the Indigenous traditional owners of the Great Barrier Reef. And so within our program, we have a self-imposed rule that we don't do any research on sea country without the express free, prior, and informed consent of the particular traditional owner, Indigenous group that historically looked after that sea country in the past. And we've also done a lot of community engagement where we go and set up community panels with members of the public, and they last for a year with meetings every couple of months. And basically they're designed to facilitate two-way learning between the scientists and the public. And so the public learn about the research, and then the scientists are actually able to take into account when designing and conducting the research the views of and the aspirations of the public. And so through this work, we've now been able to actually measure that expected change in the droplet size distribution in the clouds resulting from the extra sea salt cloud condensation nuclei that we're supplying. And we see in practice what the theory over the last 30 years predicted, that shift in, so that the number of droplets within the cloud increases and their size decreases. But there've also been quite a few surprises in terms of exactly what that looks like in practice, and how the sort of sea salt aerosols disperse and are advected into cloud much more rapidly than the theory predicted. And so I gave you the simple version of how marine cloud brightening works, but if you look at the picture at the top here, there's actually a very, very complicated, and there's a whole suite of cloud microphysical processes that are impacted by adding these extra cloud condensation nuclei. And so those initial processes, the change in cloud droplet size distribution, circled in green there, is the processes that we've been studying so far in the last few years. But When you add the extra particles to the atmosphere and they're taken up into a cloud and the cloud's brightened, then there's a whole bunch of other subsequent processes over the lifetime of that cloud that are then impacted. And some of these can make the cloud even brighter, but some of them might actually work against the brightening. And so the next stage of this research over the next 5 years is to increase a little bit the size of the experiment to about 10 by 10 kilometers, and to start to look at those processes that play out over a little bit larger spatial and time scale. So that play out over a couple of hours, say after the cloud is impacted, up to a couple of hours. So thank you very much. There's a lot of people to thank. There's been up to about 70 researchers working on this program over the last 5 years. And so I've just given you a very high level overview of the research. Thanks. I can't hear you, sorry, Hugh.
Well, thank you very much, Dan. That was excellent overview. Pretty impressive that you've managed to be out there doing stuff like this. And around the world, people have been having difficulty getting out there doing things. So that's wonderful experience. So I'm going to invite Clara and Leonardo onto the panel. We've got two mics that will share. Obviously, the camera that we're using is over there. Why don't you sit there? Why don't we sit there? So Clara, let's begin with your thoughts on what you've heard, and generally speaking, about Brightening, and what's your perspective, and perhaps a little bit about your background as well.
Sure. One that I think for me, talking about Cloud Brightening is especially important because I was there huge with them 3 years ago. And like you said in the beginning, it's a technology that's being tested and amongst all of the SRM technologies. It's the only one that has now succeeded in having the outdoor experiments happening. And I think the reason that might explain it is because they're doing a really good job in engaging, like Dan said, not just with the Aboriginals, but also with other communities that are there. And I guess the question of this event is, can MCB save the Great Barrier Reef? And we don't know yet, so that's why we should keep doing research to see if it's not the solution, but one of the many solutions that could help them with. And yeah, I don't have any problems.
So yes, so this has become another way. So your perspective, your thoughts on what was read from that.
So it was a bit difficult. We were here, but it was great to see like the footage and how that experiment has advanced. And so I work at Ocean Visions, and at Ocean Visions we are encouraging field trials. We're encouraging the understanding of technologies, and we are also urging transparency, which is Clara was saying. It's really important that this work has covered most of these elements. And I think it's really it's key that this is happening in a moment when the opposition, this type of work, tends to go kind of against scientific process. It's say the non-use agreement as the one good example of this type of opposition. That more than the non-use component, it's targeting scientific actions.
So tell us a little bit about the non-use agreement.
So the non-use agreement has, of course, several elements, but the campaign itself one of the actions of the campaign is prevent any outdoor experiments.
So this was about, what, 2 years ago now, I guess. There was a, can you give us a bit of background of what the non-use agreement is, those who might not have heard about?
So maybe Clara can give you more context, but so this is a group of scientists who are saying that pretty much these types of techniques are ungovernable and that there is not enough capacity around the world to proceed with them. And this is where this creates kind of it doesn't create a distinction between what is research and development work and what is deployment work. And one of the ways that this kind of blurring of these lines happen is by targeting science, targeting scientific activities, targeting outdoor experiments, targeting funding. They're trying to prevent any public funding for this work and also preventing consent, as they call it, at international level. So trying to keep this out of the agenda. So what is happening here by having this conversation and the UNESCO event, in a way, is support this action, support the need for the understanding of these techniques. But yeah, what is happening at that level through those say they're understood the problem is that none of this should proceed, and that is where we are getting and close, and there is only one way to deal with this. And as someone from Open Out the Arctic, this organization in Finland, is saying the real techno-optimism today is to believe that we will get anywhere close to planet targets, planet goals by purely following as you were mentioning at the beginning, the carbonization cycles.
So Dan, this non-use agreement does blur the distinction between research and deployment. How do you categorize your work? Research or deployment?
It's very much research, Hugh. At the moment, the technology with all the work that we've done is only able to influence sort of a small patch of cloud, and our research is focused at understanding the basic principles. Do the cloud microphysics respond how people have suspected and theorized over the last 30 years? And how can we understand how much the cloud responds, and how can we understand what the risks might be? But the experiments are incredibly small scale, and it's a very long way off, I think, before the technology could be scaled up for even an area as large as the Great Barrier Reef, let alone sort of a global application. I think there's probably also an important distinction there as well, that the use case that we're looking at marine cloud brightening for over the Great Barrier Reef, it's very limited. It's a regional application, intermittent sort of, so you could go and do marine cloud brightening potentially one day in the future in response to a marine heat wave that was sort of going to bleach the corals. It's very fundamentally different than using the same technology, but trying to use it on such a scale as to cool the whole planet down, in which case you'd need to presumably do it continuously and sort of all the time.
So in the context of the non-use agreement and research versus deployment, perhaps Clara, you might have some thoughts about how do we communicate to people who there's no reason why people should know very much about the background of the details, what SRM is, solar radiation conflict, and what Marine Cloud Brightening is. But the idea that they're worried that we're going to go into doing it, into deploying it, and seeing the work that Dan is doing. You see, there's proof. It's not just research, they're actually doing it. And as Dan clearly says, look, this is such a tiny start to try to understand. Yet to communicate that national issue. Are we not doing a good job of it, or is it what's happening that makes it so difficult for us to communicate this with?
I think very important point is to clarify that the researchers, they don't want the status quo to remain status quo, right? I feel like there is an impression when people don't know about geoengineering that people are doing research just so we can keep business as usual. But then if you actually hear presentations like Dan's or like yours at the beginning, you see that most of the research community is actually saying that none of this will ever work if we don't like drastically cut emissions and really focus on mitigation and all of the commitments that countries have technically already made, right? And for me, that's something that's like a very important conversation start. Because then we already kind of lay the groundwork for like trust, really. It's very easy not to trust people, right? Especially when it comes to those like big technologies and things that could look very techno optimistic and things like this. But we don't even know if those technologies could work at scale and if they can actually have the potential to pull in the dimensions that we would need. So for me, if you start the conversation by being really humble that we don't know, like we don't have the answers. But the one thing that we know is that we should have mitigation as the priority. Then I think it makes it easier to talk about research.
You have worked, you still work a lot with young people who really scared and mistrustful, I guess, with technology. How is the best, or how do you engage with people who are mistrustful of this whole technology, mistrustful of us?
Could you open the floor for questions instead of being the one who comes and just gives all the knowledge and says this is what you should think? No, you say like this is the situation we're in. These are some of the technologies that are being researched. What do you think about it? So you don't try to impose a specific opinion on them, but you actually inform so that they can make their own mind.
So here we are. Oh, by the way, I am going to open the floor to questions. So people, the audience here, if you think of questions, then I'll give you an opportunity to ask them. But here we are in Belém in COP30, and there's very little discussion about geoengineering at this direct. We've got a nice audience here, but it's a small audience with tens of thousands of people here. How do we get more discussion there? I don't know. Yeah, what do you think about that?
Two things. So one is, of course, many of the things that are being discussed here are things that are part of the agenda of negotiation. So this is not necessarily there, and so that's one piece. And the other element is, I think it's important to put this in the table, but specifically on this point of awareness, and this point of understanding that none of these techniques are ready for deployment, or most of them. And these are all, in a way, hypotheses, like ways to address specific issues. So one very large issue, we bundle it all together as a climate crisis, but then regional issues like the bleaching of corals, and regional issues like what we are working at as conditions on, which is Arctic sea ice. So we are trying to bring the concern about the need to restore, repair those very critical marine ecosystems. We don't know yet what will specifically work. So everything that's happening right now is how do we do this kind of accompaniment through each pathway and all the requirements, because it's not just technology, but it's the entire design of how this would ever be brought into the world at scale. And there are so many questions about it. I think those are the very important questions to have right now. And that's again where there are these distinctions and very important distinctions. Because bringing the conversation, as you say, of geoengineering here doesn't mean coming here to necessarily promote a very specific technology, but I think it's much more this exercise of understanding what would entail to advance this work any farther.
It is interesting when you speak to people who are really opposed. You speak to people who are really opposed to SRM. And
Sorry, Hugh, could I share something?
oh yeah, I was just going to say that you discovered though that people know very little about SRM. Yes, Dan, absolutely. Please, Dan.
I was just going to say, I guess I think it's very context dependent. So, for example, what we're doing on the Great Barrier Reef, I'm not sure that it has been so tough to communicate to people. So, if I could just share a slide for a second. So we've done a lot of work in trying to communicate to the public why we're doing this research and what it's all about, and yeah, well, essentially why we're doing it and what we're doing it, and we've tried to be totally transparent in the research. And at the same time as we're doing that and we're doing all those community engagement activities, we're also work very closely with social scientists to understand how the community feels about this research and how they want to see it proceed. And so this is a national survey of Australian residents very early on in the program, at the sort of the outset of the program. And actually, we've repeated this survey more recently. The social science team has, and the sort of acceptance has moved a little bit further towards accepting of the research. But you'll note that perhaps unlike ideas to try and apply global solar radiation management to cool the whole planet down, the sort of people strongly against this idea are very few, sort of less than 20% or something of people there. And so I think the people are fairly sensible, right? I think that they can understand that a sort of intermittent use of SRM at a regional scale to address a particular warming problem carries a lot less risk, but also potentially benefits than trying to globally sort of take control of the planet's thermostat and cool it back down, which obviously has much larger risks and potentially arguably larger benefits. I guess if you could do it in a sort of a socially acceptable and environmentally unrisky way. That was
Well,
all.
once again, when was that survey done? And that was, it says 2019 in the paper. I guess the survey would have been done for that. But maybe that survey was done 10 years ago. Do you have any sense of how that would look differently now?
Yep. So this was done at the start of our program. So it was done in 2019. When we were sort of, and this was a large survey of the Australian public where we laid out all of the different ideas that we were looking into to help the Great Barrier Reef, and asked the public to sort of to rate how they felt about each of the ideas.
Just lost
And
you
so
there,
we
Dan.
have.
Just a sec.
Oh, sorry.
But you're still.
I'll try again.
Yeah.
So this survey was undertook in 2019 at the start of our program, and it was part of a survey to ask the public about all of the ideas.
Yeah.
Can you hear me?
Look, we're back again. Yeah.
You can hear me? Okay. So this was in 2019, Hugh. The survey was done the same time it was published. And this was at the start of our program. So in the survey, we laid out all the different ideas that we were going to look into as part of the Great Barrier Reef Restoration Program and asked the public what they thought about the different ideas. But we have repeated this survey recently, and I think the recent survey has just been published, and the acceptance of cloud brightening has increased.
Well, that's encouraging. So now we do have a question from the audience. I think you can state your name and affiliation and ask your question.
Yeah, good morning, everyone. Thank you so much. I don't have as such question, whether it's a comment that we were talking about the trust issue and misinformation. I think this is a sort of global issue we do from the global south. I'm attached with the university in Pakistan. My name is Mumtaz. We do have a project on the similar line, and the initial survey indicated that the public and even the policy state, the decision maker, they are not well informed about the concept of SRM. So we are taking it parallelly, as well as you mentioned about the involvement of the young people in the individual, how we can involve them. For that, we develop kind of framework in our what we are trying to do. When I will back in Pakistan, we already established a setup. We will visit the universities across Pakistan on the both side, not only the science individuals, but at the same time, the social scientists, they will be the part of those kind of seminar. And we have requested to our education division, which is the regulatory body in the country. They will probably they will allow us, because we are already in touch with them. And we are trying to educate the students at the community, not only just on the science side, but the physics side. And our team consists of scientists as well as the social scientists. The both aspects will be covered in each seminar across all the universities in Pakistan. This is what we are trying to disseminate the information of the side. Thank you.
That's great to know. Visual tools. Yeah, I've talked about it.
We do need to be engaging with young people. I guess it was South Africa, this problem is not going away. And the young people very quickly into being influenced from decision makers. And it's really important. Having never knew they are getting involvement with youth in
I feel like I'm taking for you. Because Clara is part of at Ocean Nations, we are working in this element. And I would say that is not out of not necessarily something that we started, but something that was kind of requested from us. So when we start like our main program started on carbon removal, so marine parasite removal, and out of that initiative, we start getting more kind of questions about how we will kind of work with different groups. Something we emphasize a lot is multi-sector engagement and collaboration, and then we start getting also this concern about like this. So what is the role of youth activists or youth scientists? And we address this problem from the perspective specifically of scientists. And now it has been floating, but our initial target for our work was to, for example, in Kenya, we started working with the Technical University of Mombasa, and we started with the questions around MCDR, and they themselves found their way into SRM and different variations on climate interventions. And now it's like very quickly they're going into this process of to their own methods and workshops and all sorts of collaborations. And now there are certain groups. Africa is a thing where we have very engaged youth groups are addressing questions, but also examining potential I would say initiatives like Degrees are doing a really great job at bringing the resources so that research and the dialogues can expand. So the DSG has pioneered a lot of these conversations in several parts of the world. And I would say that in all of these initiatives, the youth component has been prominent.
And what to the two of you, three of you, Dan, and what do you think about the acronym problem? I mean, SRM, MCB, SAON. It doesn't help when we keep on using these acronyms. And SRM, well, there was even a conference just early this year in Cape Town. It was called, well, there's SRM 360 and SRM this, SRM that. And even when you explain that SRM is solar radiation, it's not a very easy, not very accessible. I don't know, an MCB, we that one. Nothing we can do about making the subjects somehow more effective. Even if we've got the thoughts about that.
What? Oh, sorry, Hugh. What was the last bit?
I don't know whether you've got any thoughts about, we talked about these acronyms, MCB and SRM and SAI. Whether the world there needs some softer names and none of these three-letter acronyms.
I'm not sure it's such a big problem. I guess scientists always use acronyms amongst themselves. I guess it's really a problem of translating the science to sort of science communication is where we need to be careful. I think not to keep using the scientific lingo and not to keep using the acronyms when we're doing science communication. But amongst scientists, it's very normal, as you'd know, to use acronyms and language that's not accessible to the wider public necessarily.
Yeah, I agree with that. I think as long as you're explaining what the acronym means and it's what the technology you're talking about is, it's not as bad as it seems. But usually when I'm talking about with someone for the first time, I say find out certain technology, but then I bring on the other terms. But it's if you just say climate intervention or geoengineering, then like it's abstract. So you need to make the expression or the acronym or template.
So we have our aggregate Center for Climate Repair. And then we got up again, oh, that's just another word for geoengineering. We're just trying to disguise what you're really doing. So my sense is that if you call a spade, you can't pretend. You can't, we're not reinventing anything. These ideas have been around for a long time. So my feeling is with SRM and then speaking solar radiation, outright SAI and aerosol effect. Those names have been around for a while. There's some people are using them to explain what they are. I'm conscious that we're coming towards the end of our session. I don't know, Dan, would you like to give some closing remarks before we wind up?
I don't have anything. I don't have anything prepared, but
no, but aspirations for the future, perhaps.
Look, I think it's essential that we do research. I think, any kind of deployment is a matter of public policy, right? That's a policy decision that should be made, by the public and by the public's representatives after weighing up public opinion and the sort of expert opinion and the risks and potential benefits, right? But as researchers, it's our job to find out what those potential risks are and to quantify them, find out what the potential benefits are and quantify them, and to understand the potential efficacy. I think there's a real danger that people just assume these ideas will work and could therefore be deployed at some point in the future if we decide at some point in the future as a society or as a global society to deploy them. But if we don't do the research to really understand them, we could be completely wrong about whether they'd even work or not. And so I think you should think about research really quite separately to thinking about deployment. At least in my view of the world, scientists should do research so that policymakers understand the implications of the policies that they may or may not make.
Well, touching on what you just said, and going into later, we are dealing with this problem here. We are using a lot of research and development language. I think that part is appropriate to some extent, but it's a difficult thing to communicate at the same time in terms that do not create this kind of alert that there is a near like deployment in the near term. So understanding the difficulties of that process, understanding that this is something that needs to be a deliberative effort that needs to consider the unevenness in terms of access to capacity, access to infrastructure, also access to not just access, but also like different political systems. So this is a very complicated experiment happening in real time, and we need to be very conscious of it and really work on designing as much as we can something that will work for the most people in the planet. And I think that's where we have this massive experiment that is, like I said, more of a social sciences experiment happening in maybe larger scale right now, and even the aspect where we are trying to test different technological pathways to solve issues that are happening right now. So this is the problem, I think, to a point that I made earlier. We are dealing here with comparative risk assessment, and that is an important consideration. So I think the more we can guide this conversation, guide the understanding that this is not a capricious effort to just want to prove how far they can go. It's rather effort to address really big issues with very dangerous consequences in ways that can have the most effect without having too many impacts. And I think understanding that balance and that need for comparing risk is fundamental, and that's how I think we'll figure this out eventually.
For me, not just for the future, but for the present, I hope that climate and justice are always the pillar of any conversations on engineering, because we know that there historically, whenever you're talking about technologies or innovations, there are always groups that have been marginalized, and if we don't make sure that they're also part of this discussion, we just risk having them being the most impacted again. Whether we're talking about research or deployment, it doesn't really matter. And I guess especially for geoengineering as well, we should really make efforts to have these technologies not for the sake of profit, and be seen as a public good. And this goes for research as well. We know again historically, whenever the private sector sees an opportunity, they will go for it for profit making. This should definitely not be the case with SRN. And I think that's so important that we start talking more and more about this to raise more awareness and really make sure that we keep vested interest away from this one.
Well, certainly, I think it's interesting that in our recent efforts to look at the cloud brightening in the Arctic, engaging with Arctic indigenous communities. Well, really for the last 50, 100 years, they have been so badly treated. This in the last century, but their level of trust is low. And we have to work quite hard, I think, to regain that trust. No, they've been hurt in the past. And I don't want to do this again. We have to look forward. We work with them. And this climate problem is facing us all. Thank you all very much. Thanks to the GAUC Pavilion, Global Alliance of Universities on Climate, for hosting us here today. This is the 7th day of COP30 in Brazil, in Belém, and it's been great to be here. Thanks again to our panel, and especially thanks to Dan for staying up till past midnight. If people came across the technology worked very well, Dan, you could see it hear very well. So that's all fantastic. We've recorded this session, and we'll make this available on the various media channels for the city. Thank you all very much.
Thanks, everyone. Thanks, Hugh.
So good. So